Alright, we're going to pick up on lesson 5 from where we left off. Let me just zoom this a little bit. So it's just, yeah, okay. So we're going to pick up lesson 5 from where we left off. So basically, if lesson 5 is about finding all the zeros of a polynomial. So one of the things we need to know is if a polynomial is given to us, right? So this is the polynomial that was given to me, and it says find all the potential, I don't even know one, it says find all the potential zeros. And we did this whole formula of finding out which was P, which is Q, right? P is the constant and Q is the leading coefficient, but it's not just P and Q. We want all the factors of P over factors of Q. That's your formula. Factors of P over factors of Q. I wrote all my factors of P, I wrote all my factors of Q, and then divided it, and these are all my potential zeros or potential solutions. So this section, the step 3, is basically from here, how do you find the zeros? What are the next steps to find the zeros? So first of all, conjecture all the possible zeros. That means that's this step. Based on the graph and the list of potential zeros. This is what we did, not the graph, we did this, right? And then you're going to test each potential rational zero by using synthetic division. And I'll just write this down, and then I'll talk more about it when we actually do it. Each time a zero is found, thus a root. Remember, root, a zero, solution, they are all. Repeat step 5b. So again, test it on the depressed equation. Again, just write this down for now, and I will talk about it when we actually come to problem. Reading this will become more useful when you want to refresh what was being taught to you, but these are the steps that you'll do. Alright, one important thing that you need to know, it's like a math concept, right? That if something is a factor, for example, let's just take, 8. I know factors of 8 are 4 and 2, or, whatever. I know that 2 is a factor of, one of the factors of 8 is 2. When you divide 8 by 2, I get 4 and the remainder is 0. Correct? But if I divide 9 by 2, I still get a 4, but there's a remainder of 1. Which basically means 9 is not divisible by 2. So basically what we're telling you is, if there is a remainder of 0, that means that is a factor of that particular polynomial. If f is, so that's a remainder theorem. I hope that was clear. If f be a polynomial, if f of x is divided by x minus c, then the remainder has to be 0. Divided basically means it is a factor. Right? Then the remainder is 0. Okay. Let's do a quick refresher. We know how to find the remainder using synthetic division. Let's go ahead and do the synthetic division one more time and divide this polynomial by this binomial. And we're going to use synthetic division. Synthetic division, what do? You draw your L, and then what do you write outside? It's x minus 3, so it's a positive 3. And then you write the coefficient, so 1, negative 4, 2, and negative 5. And then you do your whole drop, multiply, drop mama, multiply, add. So you drop the first one, and then you multiply. 3 times 1 is 3, and then you add, so that's negative 1. And then you multiply this again, and then you add, and then you multiply this again. What's here? I see this is my remainder. So when I divide this by this, so what is my equation? My equation is basically x cubed is divided by x, so my equation is x squared minus x minus 1, but there is a remainder of, instead of saying plus, you can straight away say 8 over x minus 3, which basically means x minus 3, sorry, let me take this up a little bit so that you can see, which basically means x minus 3 is not a factor of the polynomial because there is a remainder polynomial. Correct? Because there is a factor, x minus 3 is not a factor. So that's how you check. If something is a factor, you can divide. If 0 is a remainder, That's how you, basically you check. Alright? Okay, going on to the next page. So I need to use. Yeah, here we are. Okay, so now the question is x minus 10 a factor of this? So I think all of us can do this. If x minus 10 is a factor, that means my remainder should, if yes, remainder, if yes, the answer is yes, remainder must be 0. Conceptually, everybody understands that, right? Oh, I'm sorry, I'm so sorry, you can't see that. So is x minus 10 a factor of this? If the answer is yes, okay, let me just write yes, remainder must be 0. Okay, how do you test if something is a factor? If something is a factor, you try to divide and see if the remainder is 0. So how do you do this? The same way. So you write x minus 10, so you write 10 outside, draw your L, and then write the coefficients. So 2, negative 4, negative 57, negative 40. There's no need of placeholder because all the terms are there. And then drop, and then multiply, add, multiply, add, multiply, add. Yay, 0 is a remainder. Therefore, x minus 10 is a factor of 2x cubed, the polynomial that's given to us. Everybody good? Alright. The next one I'm not going to talk. I'm just going to go ahead and do the work, and you guys just follow with me. Is x plus 2 a factor? You guys can practice before you look at this if you want, and then look at, you can pause the video and then come back and look at this. Everybody okay? Got this? Okay, moving on. Alright, we're going to do the same thing, just the question is presented in a different way for you to be able to understand how it works. Factor the given polynomial given f of k equals to 0. K is an integer, right? K is an integer. So if let's say k is whatever, f of 3. If I substitute 3 in the equation and my result is 0, that means it is a 0. That is a solution. That means k is a solution. But for me to check if k is a solution, so basically we are trying to check is negative 2 a solution. That's what I'm trying to check. And here it's not presented as x plus 2. This is a solution itself. But we are checking. It's x minus 2. So you will again do your synthetic division. What will you write outside? Will you write positive 2 or negative 2? You will write negative 2 because remember what I said? Outside of the synthetic division, you're writing the solution of x. So negative 2 is a solution. At least you're checking whether it's a solution. It's not written as a factor. Only if it's shown to you as a factor do you take the opposite sign. This is a factor. So that's why you take the opposite sign. Whereas this is a solution, you take the same sign. So I hope you can distinguish that. Okay, let's go ahead and write the coefficient 1, negative 13, 24, 108. You can hit pause on the video and go ahead and practice this and see what you get and then compare the answer. I'm going to go ahead and do this and you guys can. So yes, k equals negative 2 is a solution. Okay, but that's not my only thing that I need to see. Look at the question. It says factor. How many factors can I have? So I have, it's x cubed, so it's possible for me to have a maximum of 3 factors. It could be 2 if one of them is raised to the power of 2. The degree is 3, right? But I can have 3 solutions for x. So my factors are, so I know one factor because I just found this to be a solution. So one of my factors is x plus 2. Let's see what the other factors are. How do I find my other factors? I find this from the remaining polynomial. So this is the important thing. This is the new thing that you want to make sure. So from here, when you divide this, I get x squared minus 15x plus 54 equals to 0. How do I find my other factors? If this is factorable, you just factor it. Factors of 54 that add up to negative 15, negative 7, negative 8. So my factors are x minus 7, x minus 8. So this is important. This was an important question for you to. This is where we use synthetic division. If I have given one solution, the remaining polynomial, you can either again do synthetic division to find the other solutions, or if it is factorable, you basically factor it and find the other solution. Okay, I'd like you guys to try B by yourself, but I'm going to go ahead and do the work. But you can hit pause and go ahead and do the work, and then come back and look at the work. So I'm just going to go ahead and do the work. Sorry, my mistake. All right.